Hey, this is Daily Life, Daily Shy, Daily Life, Daily Science, Daily Math, one day at a time, learning something new. We've talked about factor trees and prime numbers and composite numbers. And so now we're going to start to apply these things, but we have sort of a basic idea of what these number properties are about. So we've learned those terminologies from the other videos. But what are some of the basic principles that we're going to be really dealing with here in this beginning algebra? Well, here is one of them. The basic principle of fractions. It says that if the numerator, maybe I can type this a little bit faster. No, I promised I would write, and I'll use good handwriting. If if the numerator, and that's supposed to be an and symbol, I'll just write and the denominator, if the numerator and denominator of a fraction are multiplied or divided by the same non-zero number, or by the same non-zero number. And you'll see this a lot in math, like some if clause and then a then. So it doesn't say then in the book, but it's the same idea. If this, then that, then the value of the chain of the fraction is not changed. What does that mean? What are you talking about? Numerator, denominator, I know what a fraction is, but what are you talking about? Multiplied or divided by the same non-zero number. So if I multiply a fraction, if I multiply the numerator and the denominator by the same, keyword same, non-zero number, then the value of the fraction is not changed. All right, give me a fraction, any fraction. Could be proper or improper. It doesn't specify which one. All right, I heard 2/3. So 2/3 is a proper improper fraction. It's a proper fraction because the numerator is smaller than the denominator. And what this says is if the numerator and the denominator are multiplied or divided by the same non-zero number. So now I just need a non-zero number. How about, I don't know, 7? Okay. So if I took 2 times 7, that would give me 14. And then if I took 3 times 7, that would give me 21. What it's saying is that the value of the fraction is not changed. Really? So 14 over 21 is the same as 2 over 3. Whoa, okay. Well, it kind of makes sense. Maybe intuitively we've dealt with stuff like this, but like, why does that make sense? It might have something to do with the factor trees that we were building before. And I'm not going to build the whole tree for 14 and for 21, but I am going to break out the 7. which is exactly what we did in order to do the multiplication in the first place. So it might have something to do with that, but I'm still not like super duper convinced of that idea. How can I really make myself convinced about it? Well, I think we'll come to that. We're gonna keep practicing with this idea, and we're gonna really start to unpack why this principle holds true. But what this is the basic principle of fractions. Let's look at another number and try to understand. 10 over 15. So this time we're actually starting with a number, a fraction rather, a proper fraction, and we want to reduce it to its lowest terms, meaning we want the numerator and the denominator to basically address its greatest common factor. New words. Greatest common factor, right? In other words, if there's a 10 over here and a 15 over here, what two factors do these have in common? What two factors do these two share? 2? No, 2 is not one of them. There's no way to divide 2 into 15. Certainly 2 is a factor of 10. Whoops. But it's not one of 15. 2 times 5 gives us 10. 5 might go into 15, well, and we know it does. All right, we came in here with some idea about math, so we know that 5 times 3 equals 15, 2 times 5 equals 10. And I mean, here are two factors of two different numbers that are the same, meaning these two numbers have these numbers in common. And in fact, there's no bigger number than 5 that 10 and 15 have in common. So we say that 5 is the greatest common factor for 10 and 15. GCF, that's my abbreviation, greatest common factor. GCF 10, 15. We'll learn about what this is, but I'm just saying, what is the GCF of 10 and 15? And the answer is 5. I just showed it to you up here. But like I said, we're going to kind of be working toward some shorthand notation as well. So what does that mean? Because I still have this 10 divided by 15. What it means is that when we look at 10 divided by 15, in essence, we're looking at 2 times 5 divided by 3 times 5. And because these are the same, if we apply the basic principle of fractions, this is where it gets kind of neat. We're just looking at 2 over 3 times 5 over 5, which, according to the basic principle of fractions here, means that 10 over 15 is the same as 2 over 3, which hopefully that's blowing your mind right now, because I also showed you that 14 over 21 is 2 over 3. So, you know, these fractions are all hold the same value. 10 over 15, 14 over 21, 2 over 3, it's all the same value, you know? So let's just do one more for this video, and then we will pause and go to the next video. And this is example 2, A and B. So here's example 2B of section 1.1 in this book. 15 over 45. All right, so we need the GCF of 15 and 45. You might look at this and say, it's got to be a 5 because I see 5 all over the place. And that's probably not a bad place to start, right? If we said, well, wait, what about 5? Maybe you'll remember something from learning your multiplication tables about 9s. Okay. And I think, you'd kind of be onto something here. So actually, let's just start here. 3 times 5, remember, because I'm just representing 15 as the product of 3 and 5. Kind of like going backwards, or I'm just representing 45 as the product of 9 and 5. And I apply my basic rule, my basic principle of fractions. And it's like I'm getting rid of this part. I'm getting rid of the 5 over 5 part. And then I have 3 over 9. Now, I don't know that we're done because in truth, I don't actually know that 5 was the greatest common factor. I just knew that it was a common factor. So that's why I put the slash here. It's not actually true that 5 is the greatest common factor of 15 and 45. But, it gave us a start, gave us some intuition about it. The problem is that I still have a 3 over 9, and 3 and 9 might also have a common factor. And it turns out that they do. So let's just find the common factors of 3 and 9. Well, 3 is a prime number, so we just have 1 and 3. What about 9? Well, we have 1 and 9. That doesn't get us very far. But we also have a 3 and a 3. And yeah, it turns out that 3 can be a common factor, but we have to be a little careful here when we're representing the numbers, just to be thorough and clear. We'll apply the rule again so that we have 1 over 3, it's 3 over 3, and it's 1 over 3. And from here, we definitely can't go any further. Like one is about as low as you can go when it comes to this kind of reduction. But was there a faster way? Yeah, I think there's a faster way. We really wanted to know the GCF of 15 and 45. Maybe we would have considered like 1 and 15 from the very beginning, because as it turns out, 45 has 15 as well. And the rest actually follows as above. We could have looked at 15 over 45 as 1 times 15, 3 times 15, and found the same answer sort of in one step. So, but if you're taking a test, sometimes you do the extra step because that's what you're comfortable with. And it makes sense when you see it that way. There's many different ways, like I said in an earlier video, to find, these kinds of things out. So just be patient with yourself, and, try what you feel is right first. And then, you can skip ahead and look at the answers to see if you got it right. That's going to be all for this video. Next, we're going to do something similar, but instead of dividing to get the lowest terms, I think we're going to be multiplying. So stay tuned.